Hey guys, welcome to our flipped video lesson on inequalities. And what we're going to do is we're actually going to have one set of notes, but two videos, just because there's kind of a lot. So you can watch one, take a break, come back and watch the other. So the first video we're going to cover, kind of the first half of these notes, is on what is an inequality and solving an individual inequality. Well, an inequality is really just setting two quantities not equal, right? It's pretty straightforward. We have four inequality symbols, right? We've got less than and greater than, less than or equal to, greater than or equal to. We read inequalities from left to right. We determine whether it's a greater than or less than, because as we read, if we get to the smaller end or the larger end first, we know the smaller end tells us it's less than, the larger end tells us it's greater than. So if you're reading from left to right, whichever side of the inequality sign you come to first, that one tells you smaller is less than, larger is greater than there. All right, the inequalities, that really shouldn't be anything new to us. We should be familiar with that. Now, interval notation is a method of expressing an interval of values. Now, it's shorthand. It's made, interval notation was designed so that it's much quicker and easier to display a large set of numbers or an interval between two numbers here. It's not going to use inequality symbols. What we're going to use is we're essentially going to use parentheses and brackets to show the start and the end of an interval. So let's look at an example here. This is also something new, guys. This is probably something new for most of us. So if this is confusing, please make sure you come to class and we can definitely talk about it more in class. And I just realized looking back, I spelled interval wrong. How about interval? Yeah, that would be good if there was a V in there. All right, so interval. So let's say we have x is greater than 4. So what we have here is we have all of the numbers that are larger than 4. Well, the smallest end of that interval is going to be 4, right? The largest that interval will ever get is going to be to infinity because we never stop getting larger. So I put the lower boundary of the interval on the left, the upper boundary of the interval on the right, and now here's how I use the parentheses and the brackets. If I'm including the 4 in the interval, it's a bracket. But since here we can clearly see x is just greater than 4, I'm going to put a parenthesis. All right, now, can I ever actually include infinity? No, infinity we can never reach, so we're always going to put a parenthesis with infinity. Okay, let's try another example here. Right, so if I have y is less than or equal to 7. So now, what is the smallest number that ever is going to be in this interval for this inequality? Well, I'm starting at 7. 7's the largest, and it goes forever getting smaller. So the smallest boundary I'm going to get is negative infinity, right? It's going to keep going forever to the left of the number line to negative infinity. The largest I'm ever going to get is 7. So that's my upper boundary. We never can include infinity because we can never get there. But on 7, you can see here that we are actually going to include the 7, which means we're going to put a bracket there. All right, so what that means is with interval notation, if it's going to be less than or greater than, we're going to be using parentheses. If it's less than or equal to or greater than or equal to, we are going to be using brackets. Does that make sense? If it does, great. If it doesn't, please make sure we come to class with questions. We are going to be using interval notation and demonstrating that with all of our examples. So hopefully it will kind of make sense as we go. But if not, we want you to ask questions. Please bring those to class. So let's look at a couple examples now where we're going to solve for our variable. We're going to graph the solution, and then we're going to write that interval in interval notation. The good news about solving our single variable inequalities is they are pretty much exactly the same as solving our single variable equations, with one notable difference, which we'll talk about here. So first thing we should notice here is that we have fractions, right? And we don't like fractions. So let's get rid of those fractions. So I'm going to use red here. So I am going to multiply the entire equation by the least common multiple of the denominator. Since there's only one denominator and that's 4, I'm going to multiply by 4. Now, remember we talked about if it's in parentheses, it's safe so that n minus 3 does not get hit by the 4. The 2 does, and so does the 3n over 4. So what I'm going to end up with then is 3n is less than or equal to 8 times n minus 3. All right, so now next up, I've got some parentheses to simplify here. So I'm just going to distribute, get 3n equals 8n minus 24. All right, I'm going to then subtract n to both sides there. Subtract 8n to both sides to get all my variable terms on the same side. And I'll have negative 5n is less than or equal to negative 24. Now here's where our catch, our difference, our big difference comes. If I divide both sides by a negative number or multiply both sides by a negative number, here I'm dividing, but it works for multiplication as well, we have to make sure we flip the inequality symbol. All right, hopefully you remember that from algebra where we talked about having to do that. Now, when we're dealing with inequalities and we're going to have to graph something in a number line, fractions are a little bit tough. So I'm okay as long as we have a terminating decimal like we have here that we write this. And I believe this is going to be 4.8 is what we're going to end up with there. All right, so now we still need to do two things. Even though we have finished solving the inequality, we need to graph it. So I'm going to create a number line here. I know 4.8 is where I'm starting here, and I don't care if you put 0 down as long as you have the starting value. Now, I have a greater than or equal to, so I'm going to put a closed circle because I am including the 4.8. And then I am looking for all of the values that are larger than 4.8, and those values are going to the right. All right, so I can clearly see that I am graphing all of the values to the right of 4.8 and including 4.8. So let's talk about this now in interval notation. So what is this going to look like in interval notation? Well, the smallest number in my interval is 4.8. The largest number in my interval is infinity. I am including 4.8, so I make a bracket. I am not including infinity, so I use a parenthesis there. Again, hopefully that makes sense. If it doesn't make sense, write it down, make note of it, come class, we'll practice it some, and we'll make sure we get that skill locked down. All right, let's look at number 2. Actually, tell you what, I want you to do number 2 on your own. Instead of us doing it together in class, I want you to do number 2 on your own. Solve it, graph it, and then write the solution, the interval, in interval notation. So that brings us to the end of the first video for these notes. We've talked about what an inequality is. We've talked about interval notation. We solved an inequality, reminded ourselves of the differences between solving our inequalities and solving our equations. And now you have one example to practice on your own. So go ahead, practice that. And then when you're done, either take a break or if you want to go right into it, watch the second video to finish out these notes.